Good morning everyone. Today I am going to start unit 1, that is Laplace transforms. Laplace transforms. So in this session we have to know the basics of the Laplace transform. So first of all we have to know when we can apply the Laplace transform. Means we have to know the application of Laplace transform. So the first application of the Laplace transform is Laplace transform is used in the signals. Laplace transform is used in signals. We have two types of signals. One is continuous time signals, and second one is discrete time signals. See, for continuous time signals we can use the Laplace transform. For discrete time signals we can use the Z transform. For discrete time signals we can use the Z transform. So this is the first application of the Laplace transform. What is that first application? Laplace transform is used in signals. We have two types of signals. One is continuous time signal and second one is discrete time signal. For continuous time signals we can use the Laplace transform. For discrete time signals we can use the Z transform. Now moving to the second application, Laplace transform is used in solving the differential equations, with boundary conditions. So this is the most important. Application of the Laplace transform. Generally, if you want to solve the differential equation, first we have to find the complementary function, and we can find the particular integral. The combination of this complementary function and particular integral is called the solution of the differential equation. But here, by using the Laplace transform, no need to find the complementary function and particular integral. Directly you can find the solution of the differential equation without finding the complementary function and particular integral. So these are the applications of Laplace transform we have. Right? Now we have to know the definition of the Laplace transform. So what is the definition of the Laplace transform? See, let f of t be a continuous function. Let f of t be a continuous function. And defined for all positive values of t. Then Laplace transform of f of t is denoted by L of f of t and is defined as L of f of t is equal to integral 0 to infinity e power minus st f of t dt. What is that? Integral 0 to infinity e power minus st f of t dt, where the parameter s is real or complex number. Right? So here L of f of t is a function of s. So it can be written as L of f of t is equal to f bar of s. Here L of f of t can be written as f bar of s. This can also be written as L of f of t is equal to f bar of s can also be written as f of t is equal to L inverse of f bar of s, L inverse of f bar of s, right? Here f of t is called the inverse Laplace transform of f bar of s, inverse Laplace transform of f bar of s, right? See here the symbol L, here the symbol L denotes the Laplace transform. Here the symbol L is called the Laplace transform operator, which converts f of t into f bar of s, and the symbol L inverse is called the inverse Laplace transform operator, which converts f bar of s into f of t, So this is the definition of Laplace transform and inverse Laplace transform. Now we have to know the definition of gamma function. What is gamma function? So this gamma function helps to do the problems of the Laplace transform. So what is the definition of gamma function? If n greater than 0, then gamma function of n is denoted by gamma of n, and is defined as gamma of n is equal to integral 0 to infinity e power minus x into x power n minus 1 into dx. So this is the definition of gamma function. What is that? If n greater than 0, then gamma function of n is denoted by gamma of n, and is defined as gamma of n is equal to integral 0 to infinity e power minus x into x power n minus 1 into dx. Now we have some properties of the gamma function. So the first property of the gamma function is gamma of 1 is equal to 1. We have to remember this result. Gamma of 1 value is what that? 1. The second one is gamma of 1 by 2. Gamma of 1 by 2 is equal to root pi. Gamma of 1 by 2 value is root pi. The third one is gamma of n plus 1. Gamma of n plus 1 is equal to n factorial. Gamma of n plus 1 value is n factorial if n is a non-negative integer. If n is non-negative integer, and also the value of gamma of n plus 1 is n into gamma of n. So this can be used if n is greater than 0. If n is greater than 0, we can use this formula. Suppose if n value is a negative fraction, then we can use the formula gamma of n is equal to gamma of n plus 1 by n. This is the formula you can use if n is a negative fraction. If n is a negative fraction, we can use this formula. So these are the properties of the gamma function. So we have to remember all these values of the gamma function, right? Now the first topic in the Laplace transform is Laplace transform of standard functions. Laplace transform of standard functions. functions. So this is the first topic in the Laplace transform. Laplace transform of standard functions. Totally we have nine formulas under the Laplace transform of standard functions. One by one we have to know that. The first one is one by one we have to know. The first one is Laplace transform of the standard function 1 is equal to 1 by s. Here s is greater than 0. Here s is greater than 0. What is that? Laplace transform of 1 value is 1 by s. Right? We can prove this one by using the definition of Laplace transform, but it is not required the derivation part of this. Just we have to know the standard formulas of the Laplace transform. Right? Now going to the second one. The second one is Laplace transform of e power at. Laplace transform of e power at is equal to 1 by s minus a. Here s is greater than a. S is greater than a. Now the third one is Laplace transform of e power minus at. Laplace transform of e power minus at is equal to 1 by s plus a. Here s is greater than minus a. The fourth one is Laplace transform of t. Laplace transform of t value is 1 by s square. What is that? Laplace transform of t is equal to 1 by s square. And the fifth one is Laplace transform of t power n. Laplace transform of t power n is equal to gamma of n plus 1 by s power n plus 1. So this is the fifth property. Right? Now coming to the sixth property. What is that? Sixth property is Laplace transform of sin at. Laplace transform of sin at is equal to a by s square plus a square. A by s square plus a square. Here s is greater than a. Right? So now coming to the seventh property. Here s is greater than 0. So coming to the seventh property, L of cos at. L of cos at is equal to what is that? S by s square plus a square. Here also s value is greater than 0. Now coming to the eighth one, Laplace transform of sin hat. Laplace transform of sin hat is equal to a by s square minus a square. Here s square minus a square. Here s is greater than modulus a. The last one is Laplace transform of cos hat. Laplace transform of cos hat is equal to s by s square minus a square. Here s is greater than modulus a. So these are the 9 standard formulas we have in the Laplace transform. Right? So one by one once again I can recall. So see that the first one is Laplace transform of 1 is equal to 1 by s. Second one is Laplace transform of e power at is equal to 1 by s minus a. Here s is greater than a. Third one is Laplace transform of e power minus at is equal to 1 by s plus a. Here what is s? S is greater than minus a. So L of t value, Laplace transform of t is equal to 1 by s square. Here s is greater than 0. S is what that? S is greater than 0. Here s is greater than 0. Now here L of t power n is equal to gamma of n plus 1 by s power n plus 1. Here also what is that? S is greater than 0. Now the sixth one is L of sin at is equal to a by s square plus a square. L of cos at is equal to s by s square plus a square. Eighth one is L of sin hat is equal to a by s square minus a square. L of cos hat is equal to s by s square minus a square. So these are the 9 standard formulas we have in the Laplace transform of standard functions. In the Laplace transform of standard functions. See, if you remember these 9 formulas, then solving the problems would be very easy. Solving the examples would be very easy. So that's why you have to learn all these 9 formulas carefully, right? Remember that, students. Okay, now some of the important note points we have. See that under the Laplace transform we have some important note points. Some of important note points. See, the first note point is Laplace transform of c into f of t. Laplace transform of c into f of t means what that here f of t is multiplied by some constant, then what is the Laplace transform of c into f of t, where c is a constant. If c is constant, keep the constant outside of the Laplace transform and apply the Laplace transform to the function f of t. Apply the Laplace transform to the function f of t. What is that? If the function is in the form of c into f of t, where c is a constant, then keep the constant c outside the Laplace transform and apply the Laplace transform to the function f of t. Next, the important point 2 is if the functions are in the form of addition, or in the form of subtraction, right? If two functions are in the form of addition or in the form of subtraction, then apply the Laplace transform to the individual functions. We can write this one as L of f of t plus, if you have the plus you can write plus, if you have the minus you can write minus, L of g of t. Right now, what is that? Second property is if two functions are in the form of addition or subtraction, we can apply the Laplace transform to the individual functions. That is L of f of t plus or minus L of g of t. Right? Under this, we have to remember very important point, that is if two functions are in the form of multiplication, then the Laplace transform of f of t into g of t cannot be splitted as L of f of t. We cannot split L of f of t into L of g of t. We cannot split them into L of f of t into L of g of t. And one more point is if they are in division form, if two functions are in a division form, that can also be not splitted into L of f of t by L of f of t by L of g of t. So these are the important points we have to remember. Right? So see here, once again I am telling you, the first note point is what that if any function is multiplied by the constant, then the Laplace transform of c into f of t can be written as c into L of f of t. And the second point is if two functions are in the form of addition or subtraction, then the Laplace transform can be applied to the individual functions, means L of f of t plus or minus L of g of t. Suppose if two functions are in the form of multiplication or in the form of division, we cannot apply the Laplace transform to the individual functions. Means we cannot split them, we cannot split them, right? Okay, so these are the important points we have to know, right? Now see here we have to remember 9 standard formula and these two important note points to do the problems on the Laplace transform. Now we can go to the example problems of the Laplace transform. Example problems of the Laplace transform. Right? So the first problem is find the Laplace transform of e power 2t right below I will write e power 2t plus 4 into t cubed minus 2 sin 3t plus 3 cos 3t. What is that? We have to find the Laplace transform of e power 2t plus 4t cubed minus 2 sin 3t plus 3 cos 3t. So how to find the solution of this problem, right? See that what do you want? We need the Laplace transform of, means L of e power 2t plus 4 into t cubed minus 2 into sin 3t plus 3 into cos 3t. Right, here see, if you observe all the functions, some of the functions are in the form of addition and some of the functions are in the form of subtraction. So what is that? If the functions are in the form of addition or subtraction, we can apply the Laplace transform to the individual functions. Means what we will write? We can write this one as L of e power 2t plus, what is that? Here 4 is a constant, keep it outside the Laplace transform. What will write? L of t cubed minus 2 is constant, keep it outside, L of sin 3t plus 3 is constant, keep it outside, 3 into L of cos 3t, right? Now what is the next step? So this is equal to, now this is in the form of L of e power 18. What is L of e power 80 formula? 1 by s minus a. What is a here? A is 2 plus 4 into, this is in the form of L of t power n. What is L of t power n formula? Gamma of n plus 1 by s power n plus 1, gamma of n plus 1 by s power n plus 1 minus 2 into, this is in the form of L of sin 18. What is the formula for L of sin 80? A by a means here 3 by s square plus a square means 3 square plus 3 into, now this is of the form of that L of cos 80. What is a here? 3. What is L of cos 80 formula? S by s square plus a square means 3 square. Now this is equal to 1 by s minus 2 plus 4 into, see here, this is in the form of gamma of n plus 1. So what is gamma of n plus 1 formula? Gamma of n plus 1, here what is n? N is a non-negative integer. If n is non-negative integer, gamma of n plus 1 can be written as, what is that? N factorial. N factorial means 3 factorial by s power, what is that? 3 plus 1 is 4 minus 2 into 3 is 6 by s square plus 9 plus 3s by s square plus 9. So this is equal to 1 by s minus 2 plus 3 factorial means what is the value of 3 factorial? 6 na? 3 into 2 into 1 means 6. So 6 into 4 is 24 by s power 4 minus 6 by s square plus 9 plus 3s by s square plus 9. So this is the first problem under the Laplace transform. Right? Now what is the second problem? Go to the second problem. See, the second problem is find the Laplace transform of find the Laplace transform of t square plus 1 whole square, t square plus 1 whole square. So we have to find the Laplace transform of t square plus 1 whole square. Now what is the solution of this one? So what is that? We have to find Laplace transform of t square plus 1 whole square. So for this we can expand the t square plus 1 whole square by using a plus b whole square formula. What is a plus b whole square formula? A square means t square whole square plus 2ab. 2ab means 2 into t square into what is that? T square into 1 plus b square. So this is equal to L of t square whole square means t power 4 plus 2 t square plus 1 square means 1. Now all these functions, what is the t power 4 2 t square plus 1 are in the form of addition. They are in the form of addition. So we can apply the Laplace transform to the individual functions. So what happen? L of t power 4 plus, here 2 is a constant, keep it outside, 2 into L of t square plus what is that? L of 1. Right? Now what is that L of t power 4 value? Now what is that L of t power 4? L of t power 4 means it is in the form of L of t power n. What is L of t power n formula? Gamma of n plus 1. Gamma of n plus 1 by n factorial. This is in the form of L of t power n is equal to gamma of, okay, L of t power n form. What is the formula? Gamma of n plus 1 by s power n plus 1. So by using this formula we can write the L of t power n value, L of t square value. So this is equal to what is that? L of t power n means gamma of n plus 1. N plus 1 means 4 plus 1 by s power 4 plus 1 plus what is that? Plus 2 into L of t square value is what is that? Gamma of 2 plus 1 by s power 2 plus 1 plus L of 1 value is what is that? 1 by s. Now what is the next step? What is the next step here? Gamma of 4 plus 1, this is in the form of gamma of n plus 1. So gamma of n plus 1, what is gamma of n plus 1 value? N into gamma of n or n factorial. N factorial. When do we have to write n factorial? If n is a non-negative integer, then gamma of n plus 1 value is n factorial. So here n is non-negative, 4 is a non-negative integer. That's why gamma of n plus 1 value is 4 factorial by s power 4 plus 1 means 5 plus 2 into, here also this is in the form of gamma of n plus 1. Here n is a 2. 2 is a non-negative integer. That's why we can use the gamma of n plus 1 is equal to n factorial formula we can use. Right? So what is that formula here? So by using that formula, gamma of 2 plus 1 can be written as 2 factorial by s power 2 plus 1 means 3 plus 1 by s. So this is equal to 4 factorial. What is 4 factorial value? 4 into 3 into, what is that 4 factorial value? Here 4 factorial value is what is that? 4 into 3 into 2 into 1. Right now, so this is equal to what happened? 4 3 is a 12, 12 2 is a 24. This is the 4 factorial value. So what happened? 24 by s power 5. 24 by s power 5. 24 by s power 5 plus what is that? 2 factorial value is 2. 2 into 2 is 4. 4 by s cubed plus what is that? 1 by s. 1 by s. This is the second problem. Right? Now going to the third problem. Move on to the third problem. So what is that here? Third problem. Right now please all of you listen to me, my dear students. If you remember the 9 standard formulas, the problems are very easy. So first we have to practice all the 9 formulas right now, which we studied in the previous videos, right? So see what is the third problem here. Third problem is find the Laplace transform of find the Laplace transform of sin 3t into cos 2t. Find the Laplace transform of sin 3t into cos 2t. Right? Now see how to do the solution of this problem. See what that? How to find the solution of this problem. What do you want? We need a L of sin 3t into cos 2t. So this is the what is that value of we have to find the value of L of sin 3t into cos 2t. Here what are the functions? Sin 3t is one function, cos 2t is second function. These two functions are in the form of multiplication. If they are in the form of multiplication, we cannot apply the Laplace transform to the individual functions. That is we cannot write L of sin 3t into L of cos 2t. But how to find the solution of this problem? We can use some of the formulas, some of the trigonometric formulas and write this multiplication in the form of either addition form or subtraction form, right? So see here how to write sin 2t into cos 2t in the form of addition or subtraction form. See here what is sin 3t into cos 2t. I am writing this one as just multiply and divided by 2. Then what happened? 2 sin 3t cos 2t. So this is equal to, right? What happened here? See here, this is in the form of 1 by 2 into, this is in the form of what is that? 2 sin A cos B. So what is the formula? 2 sin A cos B formula? 2 sin A cos B. So what is the formula of 2 sin A cos B? Sin of A plus B plus sin of A minus B. We know that sin of 2 sin A cos B is sin of A plus B plus sin of A minus B. So by using this formula, I can write the value of 2 sin 3t cos 2t. So what is that here? A means 3t, b means cos 2t. So by using that formula, we can write this one as sine of a plus b. A plus b means 3t plus 2t plus sine of a minus b. A minus b means 3t minus 2t. 3t minus 2t. So this is equal to 1 by 2 into what is that? Sine of what happened? 5t plus sine of what is that? Sine 3t minus 2t is sine t. So this is the value of sine 3t into cos 2t. See here sine 3t and cos 2t are in the form of multiplication. So that's why we cannot apply the Laplace transform to the individual functions. So that's why I am simplifying that one. Means I am writing that multiplication in the form of addition. In the form of addition, right? By using some trigonometric formulae. Now we can find the Laplace transform of L of sine 3t into cos 2t. So what is that? Now L of sine 3t into cos 2t is equal to L of what is that here? Sine 3t into cos 2t value 1 by 2. 1 by 2 what is that? Sine 5t plus sine t. Right now here 1 by 2 is a constant, keep it outside, and the functions are in the form of addition. Now apply the Laplace transform to the individual functions. Then what happen? L of sine 5t, L of sine 5t plus L of sine t. Right? This is equal to, now we can use the standard formulas of the Laplace transform. Now see here, this is in the form of L of sine at. What is L of sine at formula? A means here 5 by s square plus a square. A square means 5 square plus, this is also in the form of L of sine at. What is a value here? A value is 1. So we can write a means 1 by s square plus 1 square. So this is equal to 1 by 2 into what is that? 5 by s square plus 25 plus 1 by s square plus 1. Right? See, in the first problem we have seen that if the functions are in the form of addition, how to find the Laplace transform. In the second problem we have seen that if the function is in the form of whole square, in the form of a square or cube, whatever it may be, in the form of square, cube, whatever it may be, what we have to do first, we have to expand that one by using the formula, and then we can apply the Laplace transform to the individual functions. That is the second problem. Coming to the third problem, what is the third problem? If the functions are in the form of multiplication, by using what that trigonometric formula, I have written that in the form of addition, and then I have applied the Laplace transform to the individual functions. That is the third problem. Now coming to the fourth problem, see what is the fourth problem here. Coming to the fourth problem, coming to the fourth problem, find the Laplace transform of f of t is equal to 4, 0 less than or equal to t less than or equal to 1, and 3 for t greater than 1. What is that? 3 for t greater than 1. Here listen to me. In the last three problems, just the range is t greater than 0. That's why we have used Laplace transform of a standard function formula. Simply we have completed the solution. But here listen to me. Here we have two values for f of t. In the range 0 to 1, f of t value is 4, and in the range 1 to infinity, f of t value is 3. Means here the function is in the form of piecewise continuous. Here what that the function is in the form of piecewise continuous. Means what that here we have what that in the range 0 to 1 the nature of the f of t is different. In the range 1 to infinity the nature of the f of t is different. So the function is in the form of piecewise continuous. We cannot use here the Laplace transform of standard formula cannot be applied. So we have to go for the standard definition of the Laplace transform. By using the standard definition of the Laplace transform, we can find the Laplace transform of f of t. Laplace transform of f of t. Is it okay? So what that? See, in the previous three problems, we have only one value for the f of t in the range 0 to infinity. That's why we have applied the standard formulas of the Laplace transform. We have got the solution very easily. But here we have different values for f of t in different ranges. So that's why we cannot apply the standard formula of the Laplace transforms here. We can use the definition of the Laplace transform to find the Laplace transform of f of t. So what is the definition of the Laplace transform? So the definition of Laplace transform is what that L of f of t is equal to integral 0 to infinity e power minus st f of t dt. So by using this standard definition, we can find the solution of Laplace transform of f of t, right? So this is equal to what that here the interval range is 0 to infinity, but here we have to split 0 to infinity as what that 0 to 1, 0 to 1 and 1 to infinity. So we can split this interval as 0 to 1 e power minus st f of t dt plus integral 1 to infinity e power minus st f of t dt. Now this is equal to in the range 0 to 1, the value of f of t is 4, right? So what happened here, integral 0 to 1 e power minus st. What is the value of f of t in the range 0 to 1 here? 4. So we can write in the place of f of t, you can write 4 into dt plus what happened, integral 1 to infinity e power minus st. What is the value of t greater than 1 here? T greater than 1 means the range 1 to infinity. In the range 1 to infinity, the value of f of t is 3. So here you can write 3 into dt. Now what is the next step? See here, what is that 4? 4 is a constant. Keep it outside of the integration. So 4 integral 0 to 1 e power minus st dt plus here 3 is a constant, keep it outside, integral 1 to infinity e power minus st dt. So this is equal to 4 into what is the integration of e power minus st? See, we know what is that integral e power ax dx. What is the formula for integral e power ax dx? E power ax by a, right? We know this formula, integral e power ax by e power ax into dx is e power ax by a. So by using this formula, we can write the integration of e power minus st. Here in the place of a, what is there? Minus s is there. Then what is that? The formula is e power minus st by a. A means what is that here? Minus s. The limits are 0 to 1 plus 3 into. Now here also what that? It is in the form of e power ax. So the integration is same. What that? E power minus st by minus s. The limits are 1 to infinity. So this is equal to 4 into, substitute the limits, substitute the upper limit in the place of t. What happen? E power minus s into 1 means e power minus s by minus s. Substitute the lower limit in the place of what is that? T. What happen? E power 0. So what is that? Minus of e power 0 means 1. 1 by minus s plus 3 into, substitute the upper limit here in the place of t. E power minus infinity value is what is that? 0 minus, substitute the lower limit in the place of t. What happen? E power minus s by minus s. Now simplify this. So what happen? This is equal to, what is that? Minus 4 by s into e power minus s. So minus minus is here, plus 4 by s. Here what happen? Minus minus is plus 3 by s into e power minus s. So this is equal to, what is that? Minus 4 by s e power minus s plus 3 by s e power minus s is minus 1 by s e power minus s plus, what is that? 4 by s. So this is the problem number 4. Now go to the fifth problem. What is the fifth problem? So fifth problem is find the Laplace transform of f of t is equal to, find the Laplace transform of f of t is equal to, what that? Sin t for 0 less than t less than pi, 0 t greater than pi, 0 t greater than or equal to pi. Right, now we have to find the Laplace transform of this function. Here also listen to me, we have two values for f of t. See, in the range 0 to pi we have f of t value is sin t. In the range pi to infinity f of t value is 0. So what we have to do, if we have two values or more than two values, we cannot apply the standard formulas of Laplace transform. What we have to do, we have to use the definition of Laplace transform. So by using the definition of Laplace transform, we can find the Laplace transform of f of t, right? So what is the definition of Laplace transform? L of f of t is equal to integral 0 to infinity e power minus st f of t dt. Right, so this is equal to, now see here, what is the range here? 0 to infinity. Now we have to split this 0 to infinity as what is that? 0 to pi and pi to infinity according to the given problem. So we can split the integral 0 to infinity as 0 to pi e power minus st f of t dt plus, what is that? Integral pi to, what is that? Integral pi to infinity e power minus st f of t dt, e power minus st f of t dt. Right, now what is the next step? See, what is the next step here? This is equal to integral 0 to pi e power minus st. What is f of t value in interval 0 to pi? In interval 0 to pi, f of t value is what that? Sin t na? So just in the place of f of t you can write sin t dt plus integral pi to infinity e power minus st. In the interval t greater than pi, it is nothing but in the range pi to infinity f of t value is 0. Here f of t value is 0 into dt. So this is equal to integral 0 to pi e power minus st sin t dt plus, here 0 into anything is 0. So this value is 0. Now see here how to find the value of this one. We have an integral formula. that is, we know that, what is that? Integral e power ax into sin bx dx. We know this formula. What is that? E power ax by a square plus b square into a sin bx minus b cos bx. So by using this formula we can find the value of this integral. What is there in the place of a here? In the place of a we have minus s, in the place of x we have t, and in the place of b we have, what is that? 1 is there, right? So by using this formula the value of the above integral is what is that? E power a means minus s into x means t by a square means minus s whole square means s square plus b square means 1 square into means 1 into a means what is that? Minus s into sin, b means value 1 into t, 1 into t means 1 t minus b value is 1. So what will get? Cos, what is that? b value is 1 cos t. So the limits are 0 to pi. So next step is substitute the limits. What happens if you substitute the limits here? Substitute the upper limit in the place of t. What is the upper limit? Pi. Substitute e power minus s pi by s square plus 1 into, what happens? Sin pi value is 0. So here 0 minus cos pi value is minus 1. Minus of minus 1 is plus 1. Minus of, substitute the lower limit in the place of t. E power 0 value is 1 by s square plus 1 into sin 0 value is 0 minus cos 0 value is what is that? 1. So this is equal to e power minus s pi by s square plus 1 minus into minus is a plus 1 by s square plus 1. So this is equal to, what is the LCM here? LCM is s square plus 1. So numerator value is 1 plus e power minus s into pi. So this is the fifth problem. So these are the 5 problems we have to know carefully, right?